light off. I have a start ignition light on. There's ignition. Hold the start. At 20%, we should have 700, and that's what we got. We're actually a little cool this morning. And pressures look good. Bobby Tower, you're in.
2BD, affirmative, you're loud and clear. Locked, the doors are open and stable.
120 knots, gears coming up. Victor, I've got it trimmed up pretty well. You can have to slide here for a little bit. Okay. Just maneuvered around here whatever you want. You get off the control, see what all the lights they feel. I'll show you one day. I'll tell you what, go ahead and slide in the soft button. Go ahead. Pull it in the soft. All right, I'm going to drop flaps on you. Okay, notice it went away? Yeah. I put my droops down. The droops make a lot of difference. Now I'm going to bring my droops up. I'm going to go right in the button. Okay.
The BD-10, powerful, agile, very, very solid, very, very stable, a pilot's dream, a phenomenal piece of engineering, a joy to fly. These are typical responses from pilots about the world's most advanced kit airplane, one that rivals in many ways the performance of today's jet fighter aircraft. Using state-of-the-art materials and incorporating advanced aerodynamic and engineering concepts, the BD-10 is unquestionably the most exciting aircraft to reach the general aviation market in many years. And its time has come. After 9 years of intensive research and development, and now 2 years of exhaustive flight tests, the BD-10 is a proven aircraft, ready for delivery and ready to sweep you off your feet and into the skies. The following presentation will demonstrate why the BD-10 is the most dynamic aircraft in general aviation. We will show you what materials have been used and why, which aircraft systems were selected, and how the combination of these two has added up to incredible performance. And finally, we'll show you how you can get started towards ownership of this amazing airplane, the world's first and only high-performance jet kit aircraft. The BD-10 was designed not only with performance in mind, but also for safety, reliability, durability, and just plain old-fashioned quality. This demanded the use of advanced but proven materials. The aircraft is made up of about 60% 2024 T3 aluminum, 35% glass honeycomb composites, and 5% other aircraft-grade materials. The design objective was to develop an aircraft with a maximum structural lifespan. For the BD-10, that meant the utilization of composites and traditional bonded sandwich honeycomb panels. The primary wing structure incorporates these honeycomb panels with ribs and spar webs, providing the ultimate in smooth box beams. The sandwich panels are free of rivets, preventing local deformation or buckling at high wing loads. This design enables the BD-10 wing to be as aerodynamically smooth as a composite wing, yet be stronger, lighter, and have virtually no age limit. The outer wing panels are attached to the wing center section by 2 rows of flush steel fasteners, creating what is essentially a one-piece wing that eliminates highly stressed fittings or joints. The movable leading edge slats are composed of a graphite composite structure, and the trailing edge flaps are a combination of honeycomb sandwich panel and composite material. The ailerons are fabricated of metal honeycomb material using metal skin and a metal core. The forward or cabin section of the fuselage is primarily composed of a sandwich composite structure, formed from E-glass filaments and a 3/4-inch metal core. This section is formed in a mold and cured in an autoclave under heat and pressure, ensuring trouble-free pressurization. The midsection of the fuselage uses 1/2-inch and 1-inch thick aluminum honeycomb panels, and the aft section utilizes 2024 T3 aluminum skin in the classic bulkhead stringer arrangement. The windshield is designed to the same specifications as that of the Air Force's F-15 fighter. It's made of the highest quality 1/2-inch stretched acrylic and is rated to withstand a 4-pound bird strike at 350 knots. The one-piece canopy is also made of stretched acrylic and meets military specifications. And finally, the engine inlet ducts use composite materials in order to provide smooth, seamless internal walls and to accommodate the necessary extreme compound shape. All of these materials just mentioned are not necessarily the cheapest on the market, but incorporated into the BD-10 do ensure strength for high performance and durability to make sure the BD-10 is still flying for many years to come. The aircraft systems on the BD-10 have been chosen for their simplicity and reliability and are one of the reasons the airplane has received such rave reviews from aviation experts. The centerpiece of the aircraft is literally its engine, the CJ610, or the military variant, the J85. Both have been used extensively in commercial and military aircraft, establishing this power plant as one of the most reliable jet engines ever built, with a service life of about 5,000 hours. The flight control system on the BD-10 is nothing short of ingenious. In order to assure the optimum fail-safe system, only mechanical push-pull rods or torque tubes are used. This eliminates cables, hydraulics, and any electrical boosting that would add considerably to inspection and maintenance requirements. Again, the concept was to keep it simple. The BD-10 uses ailerons that are internally balanced and sealed with a flexible material, resulting in a reduced hinge moment, which allows for the unboosted flight control system. The dual rudders are mounted on the vertical fins and provide substantial surface area for exceptional yaw control at high AOA and maneuvering flight. The horizontal tail is a stabilizer elevator using an extremely strong and stiff leading edge casting. This serves both as a load-carrying member and provides an even span-wise mass balance distribution. The aircraft uses double-slotted, mechanically interconnected, and electrically operated trailing edge flaps. These, combined with drooped leading edge slats, provide for a wide range of options for takeoff, landing, and maneuverability. These devices in addition to low wing loading, account for the BD-10's low landing speeds. In addition, the BD-10 uses electrically operated, lower fuselage-mounted speed brakes controlled from a throttle-mounted switch. These allow for airborne rapid deceleration and increased drag for landing without a significant change in pitch. The electrical system on the BD-10 is all DC, using 2 main batteries and a single engine-driven starter generator. This redundant system ensures maximum reliability with internal engine start capability. An APU power plug is fitted for externally applied electrical power. The BD-10's fuel system is made up of 5 individual fuel cells located in the midsection of the fuselage under the aircraft's turtleback, which gravity feed to a lower center cell. This system requires monitoring only by the pilot, removing the need for complicated fuel transfer systems and constant pilot adjustments for a changing CG. The result is a hands-off system, unheard of in high-performance aircraft. The pressurization system of the BD-10 provides a cabin environment similar to a corporate jet. Utilizing engine bleed for pressurization, the cabin and structure are designed for 9 psi cabin pressure, maintaining 7,500 feet pressure altitude at 45,000 feet. The aircraft also has provisions for a standby emergency oxygen mask system. The landing gear is a simple electromechanical system using standard general aviation 600 by 6 wheels and brake assemblies for the main landing gear and a 500 by 5 tire and wheel for the nose gear. The brakes selected for the BD-10 incorporate 2 sets of calipers, 2 separate brake lines, and 2 master cylinders for each pedal wheel. Thus, the BD-10 has the safety and redundancy of 2 completely independent brake systems. Finally, the last aircraft system is the one you select yourself, the avionics and instruments. The cockpit is designed with flexibility in mind. The BD-10 can be equipped with minimum communication and navigation systems all the way up to a full flight director or EFIS system, complete with autopilot. The level of sophistication required is completely up to you. What makes the BD-10 so special in the final analysis is not what it's made of, but what it can do. And what the BD-10 can do is far beyond that of any other general aviation aircraft, kit plane or otherwise. During the last 2 years, the BD Jet Corporation has been testing the prototype BD-10 at their West Coast Test Center in Mojave, California. From its initial rollout in June of 1992 to evaluation of its basic flying characteristics, to cruise testing performed in the summer of 1994, the jet has come a long way and continues to bear out the dreams of designer Jim Beatty. The BD-10 has an empty weight of about 2,250 pounds and a max gross weight of 4,440 pounds. Considering the power plant for the BD-10 produces 2,950 pounds of thrust, the result is phenomenal performance capabilities. Takeoff distance for the BD-10 is frequently less than 800 feet, qualifying it as a short takeoff and landing aircraft. Rotation begins at speeds as low as 90 knots for light loads and up to 100 knots for heavy loads. Even more amazing is that those speeds are regularly achieved in under 6 seconds from rollout. Landing distances are somewhat longer, around 1,500 feet. Under typical conditions, a comfortable landing approach can be made as low as 100 knots, with touchdown around 85 knots. With the advantages of the slat flap design, test flights have shown stall speeds in the mid-70s. The advantages of this low-speed, high-thrust capability are definitely in favor of the general aviation pilot. In the words of Skip Holm, Beatty's chief test pilot, "A pilot can do a lot of stupid things close to the ground in this airplane, add power, and get out okay." Probably most impressive of all is the BD-10's climb rate, untouched by any except the most powerful jet fighters. In flight after flight, the BD-10 prototype has shown climb rates in the 12,000 foot per minute range, passing 10,000 feet after only 35 to 40 seconds. Future production models are expected to reach as high as 18,000 feet per minute climb rates. BD engineers have also determined that the aircraft has ample thrust to push it through transonic to supersonic speeds while maintaining adequate control. This phase of flight test will be performed in the near future, with capability released once it has been established that safety will not be compromised. Inevitably, the question arises, how can I possibly build such a sophisticated aircraft? It is true the BD-10 is far more complex than the average home-built aircraft. Nevertheless, you might be surprised to find that it is still somewhat less difficult to build than a light twin. In fact, the first production BD-10 was completed in less than 10 months at the owner's own facility. Ample support is available. In order to support new owners in the building of their BD-10s, the BD Jet Corporation has established an extensive advisory program, as well as entered into a joint operating agreement with the Fox Aircraft Corporation in Minden, Nevada, which provides owner assembly assistance in building the BD-10. These programs and facilities use only factory-approved jigs and fixtures and provide complete assembly assistance to the customer. But the support doesn't end there. In addition, BD Jet has established a thorough flight training program, approved by the FAA, which includes classroom instruction and hands-on flight training. From the time you sign on as a new owner in the BD-10 program, BD Jet will guide you through every step, from initial delivery of your kit, to setting up shop, to completing and flying your BD-10. BD Jet has established new industry standards with the introduction of the BD-10 and is looking forward to your participation in the new world of high-performance jet kit aircraft.